Hi, everybody. We are going to look at scientific notation, and I apologize in advance for our reflections on the board. Sorry, you're going to have to deal with it. Here we go. Scientific notation. First, we need to know what it is. Scientific notation is a method of writing numbers that are really, really, really big or really, really small. So think of like the weight of Jupiter. We can't really describe that in terms of like what it truly is and really conceptualize it. So we might as well write it in a way that at least helps us deal with the number. And so we can use scientific notation to do that. So like the weight of Jupiter is massive, right? So we can make it into a number that's a little bit more manageable. Now, that being said, a little bit more manageable is relative. We have learned already with exponents, manageable means a lot of different things. So scientific notation can be more efficient in some ways. In other ways, it can be a little bit confusing. So we're going to be playing around with this and truly start to get sort of a feel of this. So scientific notation. These two numbers are written in scientific notation. We have 3.5 times 10 to the 11th power and 9.98 times 10 to the negative 7th power. Now, the first number in scientific notation, if it is truly written in scientific notation, this first number will be a number that is greater than or equal to, but equal to 1, but less than 10. So in other words, the number that is in front of the decimal point will be a one-digit number. After that, all of the rest of the numbers within whatever number that you're representing are going to be behind the decimal point. So 3.5 times 10 to the 11th, this number is massive. It's like in the trillions. And so looking at this number, or actually in the billions at least. So 3.5, this 3 is a number that is greater than or equal to 1. Yeah, and it's less than 10, and all the rest of the numbers behind it. Same thing here with this 9.98. This number is greater than or equal to 1 and less than 10. Now the number behind it, this times 10 to the 11th and times 10 to the 7th, this value is what's called a power of 10. Okay. So that times 10 to the 11th or times 10 to the 7th is also a trademark part of scientific notation. If you have created it right, or if you have created it correctly, this is essentially how many times I'm going to multiply 3.5 times to get this final number if I were to write it in standard form. 9.98 times 10 to the negative 7. This is how many times I'm going to divide this number by 10 to get that super tiny number. So if I were to look at either of these numbers written in what's called standard form versus scientific notation, I would be looking at saying 3.5. See, can you see that? Yeah, good. 3.5 times 10 to the 11th is essentially me saying 3.5 and then moving this decimal point over for every single time I am multiplying by 10, because every time I have this 10 to the 11th, I'm multiplying this by 10, 11 times. So I'm essentially saying I am moving this decimal point over because every single time I multiply by 10, that's essentially me just making this number like 35, 350, 3,500, blah, blah, blah. So I'm going to move this decimal point over 11 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times. That's a lot. And essentially all the other numbers that I'm going to fill this in with are zeros because it's not indicating any other numbers besides this 5 behind it. That means the rest of the numbers in this one are zeros. So 3.5 times 10 to the 11th power, if I were to write it as a number in standard notation, I'll now put my commas in, I have 350, what is this? Thousands, millions, billions, 350 billion. Get all my zeros in there. 350 billion is truly what that number is. That's a massive number. That's huge. 350 billion. Now, on top of that, I can also write 9.98 times 10 to the negative 7th. If I were to write that out in scientific or in standard form instead of scientific notation, I would write this. 9.98 times 10 to the negative 11. Actually, I should do this. 9.98 times 10 to the negative 7th power. I'm going to write an equal sign and leave a lot of space this time. I'm going to write 9.98. And this time, because this is a negative 7, that means I'm making this number really small because I'm dividing by 10 over and over and over again. So by dividing by 10, I'm essentially moving this decimal place over. So this number becomes infinitesimally smaller. I'm going to move this decimal point over 7 times. 1, 2, 3, 4, 5, 6, 7. I didn't even give myself enough space. So now if I were to add this, all of these numbers that are in front of this 9 are also zeros. So if I were to rewrite this, I have 0 point. Here's where my decimal point is. Then I'm going to write 1, 2, 3, 4, 5, 6 zeros behind it before I write any of these numbers here that matter. So if I'm talking about this number, here's tenths, hundredths, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions. So essentially I have 998 billions for this one, which I might have just screwed up. Sorry. So yeah, big numbers, small numbers. Scientific notation is looking at how to write these super tiny numbers or super big numbers in ways that we can actually manage them a little bit better. All right, so if I were to be given a number that I need to write into scientific notation, say I have this number here. This isn't a very big number. However, we can deal with it. We have 98,760. I need to write that in scientific notation. So if I were to write this in scientific notation, I need to pay attention where the decimal point is, which is after this 0. And now I am going to essentially figure out how many times I would have to move that decimal point over to the left, which means I'm looking at creating a positive power. So I have 1, 2, 3, 4 movements. So I'd rewrite this as 9.876 times 10 to the 4th power, okay? If I were to look at a really small number, say 0.0029, and write that in scientific notation, again, I'm going to pay attention to my decimal point, look at where it needs to go. It needs to go in between that 2 and the 9. Okay, so I'd write this as 2.9 times, and I went backwards 3 times, 2.9 times 10 to the negative 3rd to rewrite that in scientific notation. All right, we got a lot of videos for this one. This was a long video. Hopefully my next few videos aren't as long. However, we have 3 more videos after this, and then you can start working on your must-do practice problems and your exit pass. Bye.